Hi guys, a very warm welcome, and in this video we are going to talk about well-architected framework. So after completing this module, you should be able to design the resilient architecture, design the multi-tier architecture, and design the performant architecture. So let us first understand why do we need a well-architected framework. The well-architected framework means that how good your architecture is in terms of operational excellence, security, reliability, performance efficiency, and the cost optimization. So when you create a solution or deploy a solution on the AWS cloud, if your architecture that you have created follows these 5 pillars, then it will be considered as a well-architected framework. So well-architected framework helps cloud architects to build applications that follow these 5 pillars. Now how we have to build the well-architected framework? First of all, we should build and deploy the solutions faster, and for that we should test the system regularly. We should use automation as much as possible, like for example using a CloudFormation, using Elastic Beanstalk, using the Lambda functions, and this way we can deploy our services and the resources very quickly. Lower or mitigate the risk. Understand risk in the architecture and address them before deploying to production. So there has to be a thorough discussion, thorough brainstorming before deploying the architecture on the AWS with respect to cost estimate, with respect to any gaps in the solution, and how the maintenance and the monitoring of that solution is going to be. What about the failovers? How the redundancy, and what is the backup plan for the disaster recovery? These are the risks that needs to be identified before deploying any kind of a solution to a production environment. Then we should be able to make the informed decisions. We should be able to determine the pros and the cons of the architecture decisions for performance and availability of your applications and business outcomes. Then we should also learn the AWS best practices and the recommendations. So we should follow some case studies that the AWS offers, refer thousands of customer architecture and trainings to take the best architecture design. So AWS gives us and recommends their best practices. We should follow that in our architecture deployment, even the architecture design also. And apart from that, the similar to our requirement, we should also look into the case studies that how it was done by the organizations in the past. So the 5 pillars of a well-architected framework are, first of all, the security, second, the reliability, third, the performance efficiency, fourth, the cost optimization, and fifth, the operational excellence. So we need to ensure that our solution is properly secure from every aspect. Since cloud in the market, there is a perception that cloud platforms are not that secure. So we need to ensure that the security of our architecture has to be thorough. It should be a reliable. In case of any downtime or failure, it should be able to switch to another environment or another application. Performance efficiency. It should be performance efficient. Whatever resources that you are going to create, you need to ensure that you have designed or selected the proper capacity of those resources. And apart from that, we need to do the cost optimization wherever it is possible. Last, after the project or the solution is deployed on the AWS cloud, we need to ensure that there is a proper maintenance and the troubleshooting happens on the solution. If there are any errors or logs that are generated for errors, they should be identified very quickly and they should be resolved as soon as possible. So how we can design the resilient architecture? So first of all, what is resilience? Resilience is also called as recoverability. How soon we can actually recover our solution if there is any failover or there is any downtime. Resiliency is also the capacity to adapt to changing conditions as well. Quickly maintain and regain the functionality. A software is reliable if it is able to quickly recover from the failure as well. So how resilient architecture overcomes the failure? AWS provides multi-geographical regions to host your application, and here you can see all the blue dots are the current active regions of an AWS. All the red dots are the coming soon regions, and each region has multiple availability zones, and each availability zone has multiple data centers. So a resilient architecture deals with failure through high availability and the fault tolerance. That means, let's say if you plan to create an architecture or if you plan to create a solution on the cloud, you can select a region. Let's say I select a Mumbai region, and in the Mumbai region I have 3 availability zones. So I'll spread my solution in such a way that it should be available in all the 3 availability zones, and that makes my solution a highly available solution. In case if I need to plan a backup also, a disaster recovery also, so I may go with any other AWS region for creating a backup of the same solution. And whenever that kind of a failure happens, it would be quickly, or the traffic will be quickly shifted to that backup solution. And that is what the resilient architecture overcome failure means, based on the proper design and the implementation. So here you can see this is an example of a design resilient architecture. It's a 2-tier architecture only, and you would see that the user tries to access a web page, and from the Route 53, which is a global service, the request is sent to the load balancer, and the load balancer forwards that request or distributes the traffic equally to the web instances in the different availability zones. And these web instances are connected in the backend with the master database instance, and this master database instance synchronizes the data to the standby database instance in a different availability zone. So this is basically an example of a 2-tier resilient architecture. And how it is resilient? For example, let's say if a web instance fails, we have another web instance that is working. If a database instance fails in the availability zone, then we have a secondary database also. In case if an entire availability zone fails, still we have another availability zone. Alright. So that was the previous example was related to the application architecture. But also when we plan the storage, so we can create a resilient storage also. And why do we need a resilient storage? Obviously, to archive the data for a longer duration of time, we require a resilient storage. To get the access of the data very quickly, we require a resilient storage. So let's say we need to access a critical file or a critical data, then the resilient storage is very important for us. The reason is, if there is any failure, that still we should be able to get that data quickly available to us. And also the resilient storage might be required for doing the data warehouse analysis, for getting the big data or doing the analysis of big data, for the backup, restore and recover data from any kind of a disaster, we might require a resilient storage. And likewise, there can be many other examples where you can use the resilient storage based on the criticality of the data or the objects that you store in that particular storage. So how to make storage resilient? There are many ways. Let's say if you are using an S3 bucket, so S3, as AWS says, is 99.9999 recurring % available, which means that based on the past experience and the past performance also, AWS recommends that S3 being 99.999 recurring % available means that throughout an year there will be a one downtime that is expected, and that too also for a very short duration. which is a very high availability. Then in the case if you're planning a database, for example, if you are using an RDS, then you can create a multi-availability zone. You can create a read replica database instances also. If you're using a DynamoDB, then it is a fully managed database service. If you're using an EBS, you can always take the snapshots of the elastic block storage attached to your instances. Likewise, you can use Amazon AWS S3 Glacier to archive the object data. Alright. And apart from that, there are file storage services also that you can use, which are also highly available. Now coming to the decoupling services. So what exactly we mean by the decoupling service, or what is the decoupled system? The decoupled system is a system where the components have little or no knowledge of other components. Mostly in the case of a decoupled solutions, the services work in the asynchronous format, which means they are working individually. They are not dependent on any other AWS service. The decoupling isolates the components of system and eliminates internal dependency so that the failure of a single component of your system is unknown by the other components. They are mainly used to create a more resilient system in case of the failure of any component. So let's try to understand that in the form of a diagram. When we talk about the decoupling services by AWS, so AWS Cloud provides services with the form of synchronous and asynchronous communication. The asynchronous services are like SQS, Simple Queue Service, SNS, Simple Notification Service, Kinesis. Why they are asynchronous? Because they are not dependent on any other AWS service. I can use SNS and SQS as a standalone service also. I can use SNS for sending out the notifications only. I can use SQS only for order processing. It is not necessary that I need to use it with any other solution. Whereas in the case of a synchronous communication, like they are dependent with each other. Let's say if I create a load balancer, which is a synchronous communication example, mostly, for example, let's say if I create an auto scaling, and with the auto scaling, the load balancer is required in most of the scenarios. So auto scaling and the load balancer becomes a synchronous communication. Otherwise, how the load is going to be distributed if multiple instances are created by the auto scaling? So it becomes necessary for us in most of the scenarios to create a load balancer with the auto scaling. What are the advantages of decoupling services? It ensures high availability synchronous and asynchronous communication between services. It helps to achieve data so as to separate concerns in the application. Gives high throughput of services. Easier management on adding features. Help to customize needs by parsing and enriching data through stream and the pipeline. So the benefit of decoupling services, if you use an asynchronous communication, you can actually move out that asynchronous service anytime from the solution. You can add on as well. It will not impact the entire architecture of the solution. So this is an example of a synchronous communication but a decoupling services, where you have two classic load balancers. If one load balancer fails, you have another one. You have a web server, one fails, you have another one. You have an application load balancer, another one, and the app servers also in the backend in different availability zones. So synchronous decoupling can be achieved by having an ALB in the application, and also if you add an auto scaling also here, still you will require the load balancer. This is an example of an asynchronous decoupling communication. Now what happens here is, the architecture is same. We have web servers with auto scaling group, load balancer, elastic load balancer, but in between the backend application and the web servers, the SQS queue has been added for the order processing or streamlining the orders. Here the Kinesis service is also used for streaming and processing the real-time data, which is also an asynchronous communication. Designing a multi-tier architecture. So guys, how to design the multi-tier application? Let's look into it. What is a multi-tier application? The multi-tier application is very popular in using user facing applications. Mostly it contains web, which is a presentation layer, then the application layer, which is a logic or the backend layer, and then the database layer. This is a 3-tier architecture. The presentation layer contains web pages, for example, the website, the front end, which is going to get the traffic from the internet. The logical layer transforms presentation layer to functionality, behavior of the application. And the database layer stores all the required data about that particular application. This is a standard tier 3 architecture. Now, when we talk about the serverless multi-tier architecture components, we have an API gateway on the AWS through which the API calls can come. And then we have a Lambda that we can deploy the codes on the Lambda functions and get the desired result without running any kind of a server. Apart from that, there are other serverless architectures, that is the microservices architecture, where we can use the Elastic Container services. We can use the help of, or we can create the Dockers and the containerized applications also. So when we create a serverless multi-tier architecture, what are the main components that we need to look into to create a well-architected framework that is secure also? So first of all, we need to look into the dedicated VPC, the non-default VPC, and then we need to create the subnets, subnet for Lambda, subnet for a separate subnet for database and the applications. In the VPC, the web servers, the front-end facing web applications would be hosted in the public subnet because they are going to get the internet access. And the application server and the databases will be hosted in the private subnet, which will be isolated. Now this is one of the example of the multi-tier application with VPC. Here you can see there are a lot of services that we have used in this particular diagram. Why it is a multi-tier application? We have a web server here, we have an app server in the backend, which is a tier 2, and then we have the databases. For example, let's say somebody tries to access yourapp.com. The request from the Route 53 hosted zone would route to the load balancer. The load balancer, based on the distribution logic, is going to distribute evenly on both the web servers, and the web servers are associated with the auto scaling group. So in case if there is a change or fluctuation in the traffic, the instances will be increase and decrease accordingly. The web servers would point or get the request from the app servers or get the details from the app servers based on their functionality, and the app servers would get the data from the databases, or they are going to write the data on the RDS database. Now this RDS database has a multi-availability zone kind of a deployment, where the master database is this one and the secondary database is in the different availability zone. Apart from that, to enhance the architecture, there are other services that has been used. For example, between the app server and the RDS database, there is an Elasticache that has been used, which increases the efficiency of the solution. Then there is an SES email for sending out the email notifications. Then there is DynamoDB for storing the data or the logs. Then there is SNS for again sending out the notifications from the web server. And then there is CloudWatch for the detailed monitoring of the entire resources. The web server is going to send the object to the S3 bucket, or it could be any kind of a media that will be sent to the S3 bucket, and the S3 bucket is associated with the CloudFront, which is a content delivery service. The content delivery or the CloudFront has a URL, a DNS that is mapped with media.yourapp.com, and somebody opens media.yourapp.com, gets to view or stream the video of that particular application via S3 in the backend. So this is an example of a multi-tier application with VPC, but it is not a serverless. It is with server, because here there are instances that are created. There is no usage of Lambda functions or the API gateways. So how we can design the serverless multi-tier architecture? The same thing, we would replace it with, for example, in the presentation tier or in the tier 1, instead of web instances. So here you can see this is a web server, right? So instead of the web server, this will be replaced with the mobile app or the API gateways. So the web server or the logic tier would be replaced by the cloud function, where the actual code would be running. And in the data tier, there will be the database. Database could be anything. It could be DynamoDB also. It could be RDS, Elasticache, based on the requirement. So that is an example of a multi-tier serverless architecture, which can also be created in the non-default virtual private cloud as well. Coming to the disaster recovery or the DR. This is also called as a BCP or the business continuity plan. Now, why we require a disaster recovery to be created? Disaster recovery is about preparing for and recovering from the disaster. For example, let's say if our solutions are running in Mumbai region or any of the regions, and that region goes down for some issues, then the entire application, entire solution will be down. So we need to plan a backup for that. So the two main things that are to be analyzed before moving to a disaster recovery is recovery time objective, which is an RTO, and the recovery point objective, which is an RPO. In the case of an RTO, the time taken to restore a business process to service level after a disruption taken place. Let's say it takes around 15 minutes to get the business process active again when the disruption has happened. So the recovery time objective is going to be 15 minutes in that case, because within 15 minutes we were able to restore a business process. Recovery point object means the acceptable amount of data loss measured in time. For example, if there is a database and the active database instance fails, the standby will take. The failover would happen and the standby will take. Or if the database, the entire region goes down and we have a backup database or a business continuity plan in a different region. So to overcome that and to point the traffic to the disaster recovery or the BCP based database, how much data will be lost during that transition? That is what the acceptable amount of data loss measured in time. So company decides on RTO and RPO based on the financial impact that the company would face when the systems are unavailable. So we as an architect has a responsibility that we should let our client or the company knows that when we plan a DR or the DR kind of a situation happens, this is going to be an RTO and this is going to be an RPO, where we can expect this much amount of this percentage of the data loss during the transition to the backup plan. Now, what are the options to implement the DR plans? Backup and restore. So you can use S3 and Glacier to produce a backup solution. You can have an S3 buckets in different region, and you can always enable the cross-region replication rule. You can have the storage gateways enabled to create snapshot of an on-prem data and store it in the S3 for a longer duration of time. Then you can also go for a pilot light. So when you go to the backup and restore, in this case, what happens is, let's say if your entire solution goes down, you use S3 and Glacier, where you're going to keep the backups and the snapshots of your current existing environment. And then quickly you'll use those backups to generate a new solution, to develop a new solution. This is one of the cheapest way of restoring your resources and the solution in case of any kind of a disaster. Then you have a pilot light. In the case of a pilot light, what you can do, you will run the most critical components of your system in some other AWS region. So for example, in your entire solution, the web application or the databases, both are the most critical components. So you would keep them running in a different AWS region at a lighter version. So this way you can do the cost optimization as well. Then you have a warm standby. In the case of a warm standby, a scaled down version of your entire environment is running in the different AWS region. And this way you can reduce your recovery time. At least it will ensure that your entire solution is running, though it will be a scaled down version. Then you have a multi-site solution deployment. So if you want your applications or your environment should be running in the same capacity, then you can have a multi-site solution deployment where you would create an identical solution in a different AWS region. So a multi-site solution runs in AWS as well as on your existing on-site infrastructure. Use DNS weighted routing when you have a multi-site solution. So you can have a same identical site in different AWS region also. You can have it in the same identical thing or the same identical solution in your on-prem environment parallelly running. And you can always use Route 53 policies for distributing the traffic. And then you have AWS production to DR using multiple AWS regions. So multiple availability zones give multi-site capabilities for the application deployed on AWS. And then obviously you're going to use Route 53 for routing the traffic. What are the measures that you can take to improve your disaster recovery plan? You should be doing testing. So AWS gives you access to perform frequent and inexpensive DR tests without needing your DR infrastructure. So you should do a lab test whenever the disaster recovery kind of a condition happens, then how the recovery is going to happen. This is just like a mock drill. Monitoring and alert. So set monitoring and alerting mechanisms when your DR environment faces server failure. Connectivity or application issues through CloudWatch and SNS. So whenever the DR happens, you should be alerted using SNS or SES notifications. Always take backups. Take regular backups after you have switched to your DR environment also. User access. Make sure that you secure access to DR environment resources via identity access management. Because when your DR becomes active, it becomes the live one. And hence we need to ensure that the proper access is given to the delegates. And only the authorized delegate should be able to access in that environment. And automation. Always use automation for your deployments with the help of CloudFormation, AWS, Opswork, Beanstalk, and many other automation services that you can look so that you can quickly get your resources active. That was with respect to the well-architected framework, guys. Thank you for watching this video.